Hey, welcome to The Explainer. You know, in a world that is just flooded with information, being able to tell a solid scientific claim from something that just sounds convincing, well, that's not just a skill, it's basically a superpower. And today, we're going to build your personal pseudoscience detector. So let's just dive right in. So, here's our game plan. We'll start with the problem itself. Then we'll uncover this one simple rule that really governs all good science. We'll look at a classic trap that pseudoscience always seems to fall into. And then we'll put together a practical toolkit that you can start using, well, today. Right. You see these kinds of claims absolutely everywhere. They're all over your social media feeds, they pop up in conversations, and they all kind of demand an answer to that one huge question. How in the world do we know what's actually true? I mean, it starts with questions that, might seem a little out there, but they have these really passionate communities built around them. You've heard this one before, right?
And then you've got the newer ones, the ones that tap right into our anxieties about all this new technology. Is this something we should be worried about, or is it just a story someone made up?
And of course, some of these questions feel incredibly high stakes, mixing up our health, science, and a whole lot of suspicion. So, how do we actually cut through all that noise and figure out what's scientific and what isn't? Well, it turns out it all comes down to one core idea, and that idea is elegance. You see, the goal of science isn't to be complicated. Not at all. It's to find the simplest, but also the most powerful explanation for what we see. It's all about explaining the most with the least amount of extra stuff bolted on. Now, the tool that scientists use for this is something called a model. And don't think of, some complex diagram. Think of a model more like a map. It's not the city itself, right? It's a simplified guide that just helps us see the patterns and navigate the world. So you can think of it like this. The goal of science is not just to collect a bunch of dots, not just to list a bunch of facts. A good scientific model, it finds that simple, clean line that connects all those dots, showing you the real pattern underneath. This quote right here really gets to the heart of it. Think about that for a second. If your so-called explanation is just as complicated as listing out every single piece of data you haven't actually explained anything. You've just made a list. Real science is about finding the shortcut, the pattern that makes reality simpler to understand. Okay, so this brings us to the biggest mistake that pseudoscience makes. It's a concept from statistics, and it's called overfitting. This is what happens when an explanation tries way too hard, and in the end, it explains nothing at all. Let's look at this visually, because it makes it super clear. So on the left, that's a good scientific model. See how it captures the general trend, the simple pattern. But now look at the right. That is an overfitted model. It's this frantic, jagged line that desperately tries to hit every single data point, including all the random noise. It has memorized the data, but it hasn't understood a thing. And this is why conspiracy theories are the ultimate overfitted models. I mean, they seem to explain everything, right? But that's only because they are so incredibly contrived. To believe one, you have to accept these massive cover-ups, maybe some secret technologies, hundreds of people who are all keeping the same secret perfectly. Each little belief is just another fragile, complicated assumption you have to tack on. All right, so let's actually put this principle to the test. Let's see how it works when we look at some real-world theories. Remember, the goal is always to find the one that explains a whole lot, using just a few simple assumptions. Okay, let's take Darwinian evolution. As a scientific theory, it is incredibly powerful. Why? Because it starts with just a few simple assumptions, like natural selection. And from that simple starting point, it explains a huge range of things we see, from the fossil record all the way to our own DNA. Now, the source material contrasts this with creationism, arguing that as a model, you basically have to put in all the information you want to get out. That means it isn't a simplifying explanation. Now, that doesn't mean it's wrong, but by this definition, it isn't scientific. We can see the exact same principle at work with climate change. The scientific consensus is so powerful because it's the simplest explanation that connects the overwhelming majority of the data points, from CO2 levels to rising global temperatures, without needing a bunch of extra contrived assumptions. Now hang on.
There's a really common trap that people fall into, and it's judging science based on its ability to predict the future, like a crystal ball. But that's a pretty big misunderstanding of what scientific models are actually for. This is such a critical distinction. A prediction, that's a bold claim about what will happen. A projection, on the other hand, which is what a lot of scientific models give us, is a very rigorous if-then statement. It doesn't tell you the future. It tells you the likely consequences if certain things happen. Pandemic models are a perfect example of this. They don't predict that X number of people will get sick. No, they make projections. They say, if we don't wear masks or cancel large events, then the spread will likely look like this. They are powerful scientific tools because they accurately model epidemics that we've already seen in the past, not because they're some kind of fortune teller. Okay, so we've gone through all the theory. Now let's boil all of this down into a simple, practical tool that you can use anytime you come across a new or maybe a controversial idea. And here it is, your two-question pseudoscience detector. It's that simple. First, how much stuff does this idea actually explain? Does it connect a whole bunch of different observations? And second, how many complicated, messy assumptions does it need to actually work? Remember, good science explains a lot with a little. Pseudoscience explains a lot by assuming a whole lot. So the next time you're scrolling and you see some shocking headline, or you hear a really wild theory from a friend, just run it through the detector. Is it elegantly simple, or is it just a tangled mess of what-ifs and special exceptions? So I'll leave you with this to think about. What's an idea in your own life that might be due for a quick scientific checkup? Thanks for tuning in.